So hello, everybody. Sorry for bending down. My name's Mike Esposito. I'm an assistant professor literally here. Well, not literally in this room, but at the University of Minnesota. And it's my pleasure to welcome you to what is sadly the last session of the 2023 Data Intensive Research Conference. So as I'm sure you're all aware, it's been a great conference thus far. And from the very quick peek at the presenter slides that we're about to see today, that trend is going to continue right on. I can assure you that you're going to be rewarded for sticking things out to the very end of the conference. So with all that being said, I'm going to step right out of the way in just a second and let us get to who and what everybody really came to see. Not me, but instead the presenters sharing some really novel work using a kind of creative data sets to draw the structural origins of different forms of inequity. But before jumping into things, I did want to quickly introduce each member of our panel just to kind of warm us up a bit, and so you're not just staring at strangers. And so first up, we'll be hearing from Cheyenne Lonobile, a sixth-year PhD candidate, again, congrats on that, at Penn State, who's generally interested in immigrant integration and health, and whose current strand of research examines historical trends and the migrant mortality advantage using linked US Census data. We'll then hear from James Hawkins, who is the Associate Director at the Berkeley Institute for Young Americans, where he helps manage the Institute's research agenda, which is broadly focused on advancing an equitable, sustainable, and prosperous society for current and future generations. I hope to ever do anything that important in my life. And then finally, with the truly enviable distinction of being the last presenter on the last day of the last session of a conference, we'll hear from the always impressive Dylan Connor, who is an associate professor at the School of Geographical Sciences and Urban Planning at Arizona State University, who generally studies how cities and communities shape the transmission of various advantages and disadvantages over time. Now, just in case you decide to show up just now for the conference, do note that we're going to kind of hold all questions to the end, where we'll have about 15 minutes for Q&A. So just be sure to keep track of any and all questions that you may want to ask of our presenters as they move through their work. Presenters, I guess I'm timekeeper, so just keep an eye on me. I'll be gesturing when you're at the 2 and 1 minute mark. It's going to be uncomfortable. But with all that said, let me go ahead and take my place as background furniture. And Cheyenne, if you want to come up and get us started, here you go.
So like you said, I'm Cheyenne. Hello. I am a sixth year at Penn State University, and this is a part of one of my chapters that I'm working on. So it's still in development. So any suggestion or advice I would greatly appreciate. So this data was analyzed in the Penn State FSRDC. It did go through the disclosure process, and all conclusions are my own and not those of the Census Bureau. I just want to acknowledge some collaborators I have at Penn State and Temple University working with this data. So research has largely shown that first-generation immigrants experience better mortality outcomes than their native-born counterparts. That's the epidemiological paradox, or what I call here the migrant mortality advantage. But we don't know much about their children, second-generation immigrants, and that's largely due to data limitations. Most of the research that exists now come from European studies, and they find that second-generation don't experience mortality advantage, and they suggest that this is because they don't select into the destination society because they're born there. And those social cultural protections their parents experience wane due to acculturation, where they take on those health habits of the native population. And so if that's true, then we can expect that unlike their parents, they're going to experience, their mortality outcomes are going to be influenced by factors related to socioeconomic status as a fundamental cause of health inequality, where it shapes whether and the extent to which you're exposed to disease and able to treat disease once exposed. Education itself is one of the most consistently and substantially strongest social determinants of health and mortality in the US. Higher educated adults have better self-rated health, lower mortality. But we know that the education and health gradient, or education and mortality gradient, varies across the US. So Montez and Berkman find from their 2014 study that educational disparities in mortality are larger in the South than they are in the Northeast. And what I argue is that's because education isn't just about attainment, it's also about context. So it's about how you earn your education, where you earn your education. So your trajectories are shaped by your access and the quality of education that you have. And this varies dramatically, or very a lot, I should say, throughout the US, especially in the early 20th century, when school systems are really just developing, and they're developing unevenly during this time. So I do use 2 data sets. The first one is the Census Longitudinal Infrastructure Project. So most of you probably know about that after this week. So it's integrated system of decennial censuses, surveys, and administrative records, including the Social Security and Numinant record, provides individual level context. So I have childhood and adult. So we're able to see like parental socioeconomic status, as well as like household characteristics and adult education, marital status, stuff like that. So I start with the 1940 census, and individuals are linked to their Numinant record, so their death record. I focus on children, so 0 to 19, and about 73% of those individuals are linked to their Numinant record. I then am able to link them to their adult record in either the census, ACS, or CPS for these years. For this, what I'm presenting today, I'm focusing on really the information coming from the 1940 census in terms of childhood context. And then I use the Biennial Survey of Education. This is a digitized historical records of enrollment, personnel, finances, from state and city school districts from the US from 1918 to 1958. It comes from the US Department of Education. It's the precursor to the Common Core, which is a lot easier to use. This comes from PDFs that we scan and are sometimes hand entering. And it provides information on what we're calling the county level public school investment. This is something I work on with James Bachmeyer at Temple University. And this is something we've calculated from the state and city level numbers. And so for this project, I focus on 1922 through 1946, because those are the years that individuals would have been captured in the BSE for entering an education system at age 6. So if you're born in 1940, you'd be captured in 1946, or if you're 19 in 1940, you would have been captured in the 1922 data. So I do use Cox proportional hazard models for this, looking at mortality outcomes. Individuals enter the risk that when they participate in the adult survey. So since it's 1973 is the oldest record from 1940, would be the youngest would be 33 years old. Individuals who are alive after December 31st, 2019 are rate censored, and that's because of the pandemic, trying to get rid of that potential bias happening. And then individual records that are alive, that are recorded as alive and older than 100 are removed from the sample, and that's to mitigate potential bias in terms of age reporting. And then I do have analysis separate for males and females. So how do I get second and third generation? Well, thankfully, I can see both their individual's birthplace and their parents' birthplace. So if they're US born with at least one foreign born parent, they're second generation, and I focus on these 5 national origin groups. And then if they're US born or foreign born and have 2 US born parents, they're considered 3rd+ generation. And I focus on non-Hispanic whites, 3rd+ generation, and that's just going with the literature in terms of comparison groups with mortality research. I do have a 10% sample of the non-Hispanic white 3rd+ generation and a complete count of all other groups, and that's just for data processing purposes. And so when I mention 3rd+ generation, I'm referring specifically to the non-Hispanic white from this point on. All right, so what is county level public school investment and how's that calculated? What is this coming from? So this is created using year-specific factor analysis of these 6 measures. And so it has a mean of 0 and a standard deviation of 1. So it indicates the average relative per capita public school investment, it's a lot of words, per county. And so a negative number indicates below average PSI, and a positive number means above average. So this is just telling you that the factor now loadings and the eigenvalues are strong and stable across the observation period. In a more meaningful way, I hope you guys can see the numbers, in a meaningful way in terms of what PSI looks like. So this is the average county public school investment for individuals for where they reside in the 1940 census based on when they would have entered school at age 6. So we see for 2nd generation, they have a lot higher, they live in areas with higher PSI compared to their 3rd+ generation counterparts. And even when we separate it by national origin group, we still see these higher averages. It's ranging between 0.13 or 0.4 and 0.7 is the highest. And then, well, 8.7 for Mexican second generation have the lowest, live in areas with the lowest PSI. This isn't really surprising because second immigrants at this time are really highly concentrated in the Northeast and the Midwest. And it's shown, I don't have these numbers, sorry, up here, but it is shown in this data. That's where they're really largely concentrated, when we're most likely going to see Mexican second generation concentrated more in the South, which is why we see those numbers. And so this kind of helps explain that a little bit. So this is the 1922 county level PSI across the US. So it's, of course, you see the variation across state, but then even within state, I hope you guys can see, I try to choose colors that hopefully showed a little bit better, but you can see even like in New York, there's two county areas that have really are darker, and those are specifically Rochester and Buffalo. And I only know that because I'm from Rochester. That's where they are. But there's even variation in this lighter area. That's, of course, southern regions have lower PSI, but even within there are areas that are darker. And this is 1922, but when we move to 1946, the end of it, you see a lot more variation. And that's because school systems really are developing, and we're seeing a lot more change during this time. And so we see, like in Mississippi, compared to other areas in the region, it's very low, but even within it, there's some. New York has a lot more variation. And just in terms of Florida and West Virginia and Louisiana, they disappear from our data, and they just stop reporting. And so we're working to try to figure out whether or not they have state reports. It's very difficult to find these reports. So we're trying to fill in those blanks, but we're able to kind of calculate from other numbers that we have for this area. But this is the variation across the US. So the question is then, what does this mean for mortality? And so this is showing the association between public school investment and mortality risk. And so males are in blue and females are in orange, and it's controlling for childhood characteristics, so family socioeconomic status and household characteristics, as well as PSI. And we see that for every one standard deviation in PSI, you have a 3.4% reduction in mortality risk for males and a 2.6 reduction for females. So it's a positive association, which is not surprising because we know there's a positive association with educational attainment itself. But the context also is important. So I'm interested in second generation, so that's what this is second generation immigrants. So I said, European research says second generation don't experience mortality advantage. I find that they do. And that's partly, I think, related to the fact that we're in the US, where immigration is a little bit different during this time. And so the selection into it. And so this is controlling for family socioeconomic status and childhood household characteristics. And we see among males, there's an 8.2% lower mortality risk compared to their third plus generation counterparts, and a 9% for females. So we see this advantage. And then, so we know that PSI is going to have an impact on mortality differences, and it does here. So we see that it reduces the difference that we observe. And by we, I mean you and I. There's about a 10% reduction in for males, and about I think it's a 6% reduction in advantage among females. So, but the advantage still exists. So even after controlling for these childhood characteristics, we're still seeing an advantage, which suggests that there are other factors playing into it. So that's something I'll talk about in terms of my next steps. But I'm also curious as to whether or not this is the same across all national origin groups. So do all second generation experience an advantage? And the answer is no. And it's very different depending on the group, which is not surprising during this time in terms of reception into the US, and which affects then acculturation for individuals. They're going to have different experiences and take on health habits differently across these different groups. So we see for males, they do across all groups, they do have an advantage. But for females, Canadian second generation, they have statistically similar mortality risk. But you can see Southern European and Mexican second generation, their differences compared to their third plus generation counterparts is very large. And so in terms of PSI, I was curious as to whether or not the effects of PSI are the same, given that they're very similar PSIs across the different groups. And the answer is no. So there is a reduction. Everybody has a reduction in their mortality risk advantage, but it's different across the different groups. So Canadian second generation are statistically similar to their third plus generation counterparts. For Northern Western, we see the biggest change in terms of it's a 24% reduction in mortality advantage and a 20% mortality reduction, sorry, for males and then females respectively. We see among the other groups, so Central and Southern European, it's about a 7%, between 5 and 7% reduction for both males and females. And then it's only a 3% reduction in mortality risk advantage for Mexicans. So this is all to say that PSI affects the groups differently, but it's also related to how their experiences within the US, which is really hard to say with all of this, but it's just kind of a snapshot of what I found. And so in summary, we're just, there is a positive association between the average relative PSI and mortality among US second and third generation individuals. My next step is to better concentrate on PSI and its effects, is to do models with sibling fixed effects, so I can parse out those potentially selection and cultural protections that second generation immigrants are experiencing, so we can better see the effects of PSI and mortality. And then we know that there's a continuation of the migrant mortality advantage among second generation, which is, so the paradox continues. And I can only look at second generation in terms of mortality. Unfortunately, we won't be able to go further with this data, but it would be really awesome. But to better understand it, I want to incorporate measures of, say, smoking, alcohol consumption, and obesity, which will kind of play at those health-related factors, and then also incorporate the adult-specific controls known like adult educational attainment, marital status, income, which will impact mortality outcomes. So, yes, that's it.
Hello, everyone. My name is James Hawkins with the Berkeley Institute for Young Americans, and the title of my talk today is same as it ever was, investigating homeownership across cohorts. And to take a cue from the title slide, David Byrne lyricizes in the 1981 classic Once in a Lifetime, quote, "And you may find yourself in a beautiful house." Which leads me to ask, is this as true today as it was when the Talking Heads released this pop classic 40 years ago? Many researchers have documented a decline in the rates of homeownership among segments of the population, including young adults. But more recently, there have been questions about whether young adult homeownership is actually that bad off at all. And more broadly, in the era of substantial home price appreciation and affordability issues, I believe it's interesting to ask how the housing market is affecting different age groups. Here I show the median inflation adjusted home prices that they've grown for more than 100% since the beginning of 1980. And perhaps the most intuitive result I have is whether you're feeling this is painful or pleasant. With this in mind, the goal of my talk today is to bring the latest IPUMS data to bear on this issue and answer two related questions. One, how have homeownership rates changed across time for various age groups? And two, what explanations can or cannot account for any changes across time? Throughout my analysis, I use microdata from IPUMS CPS and IPUMS USA. My main estimates are of homeownership along the extensive margin based on the Census Bureau's household measure of homeownership, with 0 defined as renter and 1 defined as homeowner among the sample of household heads, aka householders or the survey reference person. I primarily estimate differences in homeownership rates across time in percentage point terms, weighted by the household sampling weight, and I estimate this homeownership measure for single year age groups from 22 to 90 plus. So the place I'd like to start is in the year preceding the release of Once in a Lifetime, which conveniently also happens to be a cross-section of the decennial census. On this chart, the y-axis shows the fraction of householders who own a home based on the 5% sample from the 1980 census, and the x-axis shows each age group from 22 to 90 or older. As you can see, homeownership rates are characterized by substantial returns to age between 22 and 33, a leveling off up to a peak at about 56 years old, and then a gradual decline among householders at retirement age, going from a low of 21% to a peak of 79% and back down to about 63%. Here I add the 2021 cross-section from the American Community Survey in blue. Any estimate where the blue line is below the orange line shows a decrease since 1980 for that age group, and conversely, any point where the blue line is above the orange is an increase since 1980. As you can see, a gap has opened up over this 41-year period where working age householders have seen a decline in homeownership rates, and householders in conventional retirement years have seen gains. And to better visualize the 1980 to 2021 change, on this graph, I calculate the percentage point difference over this time period for each age group. We can see that the greatest decline occurred among 32-year-olds, minus 13 percentage points. The greatest gains are among 82-year-olds, plus 15 percentage points. And the break-even age of no change in homeownership is around retirement age at 63 to 65 years old. It is also worth noting that the declines were not just concentrated among young adults. Householders between 40 and 55 saw about a 5 to 10 percentage point decline in homeownership over this period. So perhaps the most obvious question about these results is whether there is something going on with the specific years that I've chosen to compare. Maybe 1980 was a particularly good year in the business cycle and 2021 a particular bad year. To test this question, I turn to the ASIC supplement of the CPS and show homeownership rates from 1976 through 2022, with the graph broken up into separate age groups with 22 to 29-year-olds in the leftmost panel and 80 or older on the right. Here I show a simple line of best fit for homeownership rates for all years in the ASIC. These results show that 1980 was a particularly good year, especially for 22 to 59-year-old homeownership rates when homeownership peaked. But it is also apparent that the change over the subsequent 4 decades does not solely represent the ups and downs of the business cycle. In the years since 1980, each subsequent peak and bottom of the cycle is lower for 22 to 49-year-olds with pronounced declines in the 80s and late 2000s corresponding with the Great Recession and its aftermath. And to step back even further, here I've overlaid the ASIC series shown as a solid line with the same homeownership measure from the decennial census and American Community Survey shown with dots. I also picture a linear interpolation between each decennial census in this period, with the exception of 1950, which does not include recorded homeownership data. A few takeaways from this graph. First is that the decennial census and the ACS do not perfectly correlate with the ASIC. For instance, the 1980 data have less of a peak. But overall, the data are quite similar, with the most notable differences occurring among the 80+ age group. And two, clearly over a long enough time frame, one can paint a picture that all age groups are better off. But this graph indicates that 1980 was an important turning point in homeownership rates for much of the population. And lastly, I'm going to look at whether traditional predictors like demographic or economic characteristics can account for or explain the 1980 to 2021 gap. I take inspiration from a model used by William Gale and co-authors in their 2020 Wealth of Generations paper. I implement 2 linear probability models. In the base model, for each separate single-year age group from 22 to 90+, I regress the household homeownership measure on a dummy variable for time period corresponding to 0 for 1980 and 1 for 2021. In the full model, I add a vector of controls for household demographic and economic factors denoted by X, which includes fixed effects for marital status, number of children, education, race, ethnicity, immigration status, and inflation-adjusted household income. For income, I use a square root equivalent scale based on the number of members of the household, and I bin the measure into weighted deciles based on 1980 values. And the intuition for the base model is that the beta term for each age group is measuring the marginal difference in homeownership rates in percentage point terms across time. This is the exact same measure that I reported previously in the main results, but translated into a regression framework. The full model is reporting the same measure, but conditional on the added controls. The calculated difference between these 2 models gives us a measure of the 1980 to 2021 gap that can be explained by these traditional predictors. So on this graph, I plot the betas for each age group from the base model. Again, this is just a repeat of the main result I showed earlier. And here I overlay the base model results with the results from the full model, which shows a percentage point difference in homeownership rates between 1980 and 2021, again, conditional on my vector of controls. A few things to take away from this. As you can see, the added controls in the full model can explain 100% of the gap for 22-year-olds, with a shrinking percentage explained as we look at late 20 and early 30-year-olds. From 40 to 60 years old, almost none of the gap is explained by the full model. And for folks in traditional retirement years, the model accounts for a fairly substantial fraction of the 1980 to 2021 gap. Between the ages 67 and 90+, the full model reduces the gap by a low of 37% to up to 100%. Next, I will decompose the explained portion of the gap between the 2 models by using a method developed by Jonah Gelbach to distinguish between the individual effects of each covariate on the explained gap. Traditionally, one would go about this analysis via stepwise regression. However, the marginal effect of any variable in a stepwise regression can be dependent on the order in which they are added to the model. The Gelbach decomposition is grounded in the omitted variable bias formula and allows one to recover the individual effect of each covariate on the explained gap, independent of the order in which they are added to the model. Importantly, the sum of the coefficients from the decomposed covariates will equal the difference in betas between the full and base model, aka the explained gap. So in this graph, I'm just showing the previous estimates for the full and base model, but highlighting the explained gap with vertical bars. On net, we can see that the controls are pushing the full model in a positive direction for 22 to around 55, and for everyone 16 older, it's pushing in a negative direction. Here, I just zero out the coefficients for the base model so that I'm measuring the marginal difference between the full model and the base model. This is important because each of these vertical bars represents the net effect of all the covariates in the Gelbach decomposition. And finally, here I'm plotting that decomposition by visualizing how much individual covariates in the full model contribute in percentage point terms to the magnitude of the explained gap for homeownership rates over time. To reiterate, summing up all these factors for a given age group nets out to the explained gap for that age group. A positive value here indicates that a given covariate pushes the full model higher relative to the base model in percentage point terms, and a negative value shows the opposite. A few important points I take away from this graph. One, marital status is an important factor, particularly for the youngest households. I think this is an intuitive result with the average age of marriage getting pushed older and older, and homeownership rates generally higher for married individuals. Therefore, controlling for this factor increases on the margin the magnitude of the explained gap, part of the homeownership gap between 1980 and 2021. Household income is a substantial factor across ages, but pushes homeownership rates lower in the full model. While I have some more digging to do here, my interpretation is that since income and homeownership are correlated and average real incomes, household incomes have risen across the population, the effect of controlling for this factor pushes the full model lower on the margin, especially for householders at retirement age. Income is an important factor for explaining the total 1980 to 2021 gap. The other covariates have a lesser influence on the explained gap. For most age groups, education pushes lower, while race generally pushes the full model higher. Number of children and immigration status are particularly important for younger householders, and region has a minimal effect on the size of the explained gap. Okay, to sum up, a substantial gap has opened up for homeownership rates in 2021 relative to 1980 for different age groups, with younger adult householders experiencing declines and householders at retirement age experiencing gains. For much of the age distribution, the gap over time cannot be solely explained by fluctuations in the business cycle or by traditional predictors. Although traditional predictors can account for a substantial part of the gap for householders at retirement age. While I do not attempt to quantitatively decompose whether this is an age, period, or cohort effect, it seems plausible that something about the housing market over time has differentially affected cohorts. And directly testing the effect of affordability issues on different age groups is an important avenue for future research. Thank you very much.
Okay, so yeah, let me just check that this. Yeah, great. So thanks everyone for sticking with us for the last session, last paper of the last session. So the project I'm going to present today is really kind of a first analysis in kind of a bigger effort that myself and a group of my collaborators are focused on at the moment. And this particular paper is in collaboration with two of my graduate students, Xicha Xie and Jiwan Zhang, and one of my former collaborators who's just moved to UC Santa Barbara, Amy Fraser. And what's distinctive about Amy in this group here is that Amy's actually an ecologist who specializes in satellite technology. So I think you'll see as the talk goes on what the relevance of that is here. So in this paper, the kind of bigger trends that we're grappling with here are basically two big trends characterizing US society over the last 150 years. One is the increasing urbanization of the US population, which is increasingly concentrated in large and sprawling and more segregated cities. And the other is the long-term decline in intergenerational mobility. And so what this paper is really focused on is starting to kind of take a kind of a zoomed out lens to try and think about whether there's a potential relationship between these two long-term trends. So what do we know about urban development and spatial development and intergenerational economic or social mobility? To quickly summarize, not very much. So there hasn't been a lot of work into the role of urban development, urbanization over time, and what that means for long-term trends and opportunity. But just to sum up a couple of the big findings that we see in the literature, one, as we all know, large cities tend to be characterized by higher average earnings, but also higher levels of income inequality. One of the really interesting findings to come out of the recent intergenerational mobility research is that actually the probability for children to move up the income ladder actually tends to be lower for kids who are growing up in larger metropolitan areas characterized by higher levels of urban sprawl and higher levels of density. And we have a paper which is forthcoming now and very recently, which actually shows that there's a rural advantage in upward mobility. So if you take two kids, both born into lower income households, actually the adult income attainment for those kids tend to be higher when they're growing up in smaller rural communities than in large and sprawling metropolitan areas, which is kind of a counterintuitive finding that we're positioning our work within. So what are we doing here? So the big question we're asking is, or tentatively asking here is, how has long-term urban spatial development in the US affected levels of inequality and social mobility? The way we're grappling with that question is we're building up a new county level database that characterizes counties across the period from roughly 1900 up to 2015. And so there's a couple of different inputs into this database. Some are going to be familiar to you. I think some might be a little unfamiliar to this audience, and I'm really happy to kind of talk about those and actually, hear your ideas if you have any of those in the Q&A. So the kind of new set of components that we're bringing into this database is a long-term series of data and observations on, that should say, land use and the use and configuration of land within counties over that period. We're bringing on top of that a new set of metrics, which are referred to as landscape configuration metrics, which describe the shape and structure of physical environments, of urban environments, helping to decompose things like urban sprawl. And then to that, we're joining new estimates of long-term intergenerational mobility. So we're looking at, for a given county across this period, what's the rate at which children born into low-income households move up the ladder as adults? And so we're pitching this as a kind of a first analysis of the interaction between historical land use change over time and intergenerational mobility. So the mobility estimates, we're relying on a couple of sources which should be familiar to people here. We're using the IPUMS linked full count census data. At the moment, we've got two waves of estimates, and we have a set of observation years from 1900 to 1920, which we use to come up with mobility estimates for the 1884 to 1896 cohorts. We have a similar set of estimates based on the 1920 to 1940 links. And then we're integrating these with the county level estimates from Opportunity Insights. And so that gives us a kind of a 3-time period and panel of social mobility estimates for all counties in the US over this period. In terms of land use change and spatial development, a kind of another hat that I've worn over the last few years has been in working with built environment and land use data, particularly using the Zillow data source. And so as part of the HISTAC project, we came up with a bunch of these measures focused on tracking land use change across the United States back to the 19th century. And there's actually a couple of different kind of competing data products at the moment in this space. And actually, I think one of the most promising is actually a recent database published by Lee et al., which actually tracks land use change at 1 kilometer by 1 kilometer resolution all the way back to the 1600s. And so that integrates many different data sets. And it actually looks, in terms of quality, it looks pretty good. So that's the data set we're using. We take counties, not to get too into the details, we're focused on county boundaries. As we all know, counties in the US are very irregularly shaped. They're kind of oddly shaped from state to state. That's a problem if you want to study spatial change within counties over time, because the boundaries actually impose a structure on the land change. And so what we do actually is we draw a 50-kilometer circle by radius around the centroid of the county. And so we actually generate these kind of county areas which are consistent over time, and which we can track spatial development across our panel period. That's just a quick snapshot of Minneapolis-St. Paul and the kind of complicated county arrangements that characterize, that underlie the metropolitan area, and then our circle is next to that. Okay, so what are landscape metrics? So this is where my colleague Amy Fraser really comes in. So ecologists have long developed this big toolkit for studying changes in landscapes using landscape configuration metrics. And effectively what they do is they take that spatial imagery that you just saw, and it characterizes the shape and configuration, the density, the degree to which settlements are scattered or concentrated. And they have a whole bunch of different indices that you can use to describe those metrics. And so part of the reason you haven't probably seen work like this in the kind of historical demography world is not just because we haven't had long-run historical land use data, but actually it's very computationally expensive to try to compute these metrics, particularly at fine scales. And so one thing we've done is we've developed a parallel computing pipeline that can kind of generate these metrics really quickly at different scales, census tracts, counties. And we actually want to make these metrics publicly available, as quickly as we can at different scales, so that other people can maybe think about how to use them in their own projects. Okay, so just to kind of keep moving, this is just a map of changes in the percentage of urbanized land over time. It looks very like the map of urban development today that we're all familiar with in the US. This is an interesting measure, and I'm going to come back to this in a second. This is one of these landscape configuration metrics. And what it actually shows is this is a metric called patch density. And what patch density characterizes is a type of urban development which is not like a big sprawling metropolitan area, but it actually shows the development of smaller settlements in a kind of a more fragmented landscape. So if you think about, if you go outside Minneapolis, the one time I've been outside Minneapolis, there's I went to a place called St. Cloud, and I went through a whole bunch of other different settlements, and actually patch density, as you can see on this map, actually tends to be really, those values tend to be really high in this region of the country where you have smaller urbanized settlements. And so this is a measure of increasing patch density over time. So what we want to do is we want to basically, we set up a two-way panel model. Our dependent variable is the social mobility rate of the county in one of our 3 time periods. And then what we're trying to do is to look at the effect of different trajectories of urban spatial development. Does the landscape build up? Does it stay relatively sparsely developed, like a consistently rural area? Does the metropolitan area sprawl? Does it fragment into these smaller settlements and so on? We want to adjust then also for all of the other known determinants of intergenerational mobility that we have in the literature, typically based on census data and administrative data. Okay, so just to give you a quick snapshot of a couple of the findings. So the outcome here is intergenerational mobility. This is a two-way fixed effect model. We're controlling for all of the things that have been documented in the literature already to be associated with intergenerational mobility, racial composition, household structure, and in these mobility models, we control for household income per capita, the share of the population in urban areas and manufacturing, and so on. And so what's really striking about this is actually the persistence of these spatial development effects on the mobility estimates. And there's really kind of two that I really want to highlight here, 2 groups of effects. And the first is we find this really powerful negative effect linking urban sprawl to intergenerational mobility. So that means places conditional on their initial level of development, places that have sprawled over the 20th century have also seen sharp declines in their upward intergenerational mobility rate across the century. And really interestingly, we see this really powerful positive effect for the density of smaller settlements. So remember, this is not a contrast between urban and rural places. These are almost 2 different types of urban development. We have, the kind of sprawl model on the one side, and then we have these kind of smaller but developing communities on the other side. And so what we're seeing is that a kind of a smaller settlement type development setup seems to be more positively associated with upward mobility, whereas sprawl is negative. Just as kind of validation, what we also do is we swap in an alternate set of outcomes, being household income per capita and the Gini coefficient for income. And what we actually see there is something different. We see increases in urbanized area and urban sprawl to be positively associated with income and income inequality. And so that really fits with how we understand the current landscape of opportunity in the US. So larger places tend to be associated with higher incomes and higher income inequality, but lower rates of upward mobility for the kids who are growing up in those places. Okay, so let me just round it out and kind of give you kind of our summary and conclusion and where we see this going. And I can talk a little bit about where we see the mechanisms. That's one place where we're really focusing our attention at the moment, is trying to think about what is linking these land use transitions to mobility outcomes. So what we find are very powerful effects of landscape changes on inequality outcomes. I think this is a whole area that we really don't know very much about, and we're still trying to think about, why is land use change important? Many of us have focused on neighborhood effects. Urban sociologists in particular have thought a lot about neighborhood effects, but where do those neighborhood effects come from? And one place might be the shape and configuration of the metropolitan area, and how the urban landscape is configured. And so we're finding strong and powerful effects of landscape change and inequality outcomes. Density and sprawl are linked to higher inequality, and smaller scale development appears to be conducive to upward mobility. And so we're kind of trying to leave this with the tagline that, at least for social mobility, what our work is starting to suggest is that big cities may be good for adults in terms of, if upward mobility is what you're chasing, then moving to a big city might be a way to achieve that. But based on what we're seeing here is that those places appear to be bad for the kids growing up in those places. And so that's what I want to leave you with. Thanks.